Hey guys, welcome back to another video of my channel. Today we are gonna solve this problem, a majority element question. Okay, so this is the question on LeetCode 169, which is majority element. Let me go to the code. Yeah. Um. So what is the question says? It says that we are given an array. Okay, we are given an array. Here the array is 2, 2, 3. Here the array is 2, 2, 2, 1, 1, 1, 2, 2. You get it. The majority element in the add element that appears more than n by 2 times means for this case, if you see as there is 3, 2, 3, the majority element is the majority element is 3 because 3 appears more than n by 2 times. Over here, n equals to 7, as you can see, n equals to 7. The size of the array is 7. So n by 2 is equals to 7 divided by 2, which is like 3. We are not including the remainder, which is like 3. 3 means we have to get the element which is greater than 3, right? We have to get the element which is greater than 3. For this case, the element which is greater than 3, which is 2, right? Now, if we come for the approach, how we gonna solve it? Okay. Immediately I can think of a two loop approach where let's say we are gonna make one loop which will go from 0 to let's say n minus 1, right? Which will go from I equals to 0 to n minus 1. This loop will gonna cover the whole thing. Okay. So let's say there is a I pointer or I iterating through the whole array, right? Here I is at 2. Then another loop will check for every element's number of count to n. We're gonna start from I. That's a 1 to n minus 1. Okay. So here the j will check for every element's count. So here I is 2. We are gonna fix the I over 2. J is let's say 2. So the count, we need to initiate a variable called count, which will get plus plus when I equals to j. So here j equals to 2, right? J equals to 2. Again, j is this 2? No. Then j will get plus plus. Again j will get plus plus. Again j will get plus plus. Here j equals to 2 and I equals to 2. So count would be plus plus and count would get to 3. Again, j is 2, I is 2, count would get to 4. If at the end we have to say if count greater than, sorry, if count greater than n by 2, then we'll gonna return the count. Okay, this is the approach for the like brute force approach I can think of. Okay, one I is for like iterating through the array and another j is for counting the elements, how many times it appears, right? So here for this approach, what is our complexity? Our complexity is O of n square. Why O of n square if you ask? Because the O of n square, because the whole array gets iterated or there are two loops which is iterating the array, right? One takes n times, another takes n times. So that's why it is O(n) square, right? So it is not a proper fully optimized approach. we need another approach which will be do better for this. Okay. So what I can think of, like, let's say we have to get the frequency of the, like, element, and get which is, like, bigger than n by 2. You get the whole point, right? If 2 is bigger than n by 2, we will gonna return 2. If 3 is, for this case, 3 is bigger than n by 2, we will gonna return 3. So what we can do is we can think of a hash map kind of approach. What we'll gonna have a hash map. Let's do a hash map. Okay. Let's create, let's say, hash map. Okay. Let's create a hash map where, let's just say this is a hash map where there is key and there is value, right? We are gonna iterate through to the whole array and put the elements in the hash map. First, let's say there is 2. We are gonna put 2. There is again 2 and first 2. Then we're gonna put 1 over here as 2 appeared 1 for this case. There would be no another loop. One loop will be done. 1 is 2. 2 is 1. Again, I will go and get over here, and then it is also 2. So we are gonna, like, update the 1 to, let's say, 2. Then I will go from here to here, then to this is 1, right? We're gonna put 1 as a key and the value of 1, let's say 1, right? You get the whole point, right? What is going on? I will go through the whole array, then we'll go get the all the frequencies of those things. After getting the frequency, right? After getting the frequency, we have to check. We have to check one thing. What? Map dot get. Okay, map dot get I, like, map dot get I. If map dot get I, sorry, if map dot get I greater than n by 2, okay, greater than n by 2, we have to return I. You get it? What is saying? Means if map dot get value of I, which is 2, let's say, 2's value is greater than the values of size of the 7 divided by 2 greater than, then we have to return the I, right? To get the whole point. So this is the hash map approach. If you want the code, I can uh, like, write the code over here right now. So what we have to do is we have to run an, let's say, loop which will get runs to array, right? This is a for each loop, and then we have to check for map dot port. Okay, map dot port I comma map dot get or default, which will check for if it is available in the map already. If it is, then it will update the value, and if it is not, it will just put it and update the value as 1. You get it? Plus 1, right? Then we have this line. Check if it is greater than m by 2. If it is, then it will return, or else it will return -1. Minus. Right? This is the approach for the hash map. And for this approach, the time complexity would be O of n, right? And the space complexity also would be O of n because we needed an extra storage to store the elements, right? We are uh, going through the array one times. That's why time complexity is O of n, and we are going through the we are storing those all elements into a hash map. That's why the space complexity of O of n, right? You get the whole point over here. This is a O of n approach, and this is a O of n square approach. But here the time complexity is O of n, but we needed extra space for it. So we need to change the time complexity, space complexity to O of 1. What we can do over here, we need another approach. Another approach, what will it have? Okay, let me copy this thing. Or let me just write this thing. 2, 2, 1, 1, 1, 2, 2. Right. Now let's say another. Okay. What will be this approach gonna do? What will this approach gonna do? Let's say mm, we can think of a current number. Okay. Let me describe it. I am gonna initiate a variable called, let's say, current number. Okay. Current number, which will be at first will be 0, right? And current number will be 0, right? And another variable which is count. Okay. Current number and count both are 0. Okay. So what we're gonna do is we are gonna iterate through the array. Right. We are gonna iterate through this array first. Iterating through this array first. Okay. Let's say this is the array we are iterating through, and then if the whole this I will gonna put the current number as I. Okay. When I is at 2, the current number will be, let's say, 2, right? Current number will be 2, and count would get to 1. Okay. Count would get to 1, right? Just remember this thing. Then I will get plus plus over here. Here current number is also true. So the current number didn't change, right? So the current number as didn't change, the count would get to 2. Now over here, just look at one thing. Here current number is not 2, right? Here current number is not 2. Then what we will gonna do? We have to reduce the count by 1. We have to reduce the count by 1. So again over here, the current number is not. So here one thing you have to get right. We are starting from I, right? I, right? Here current num is 2. We are gonna check the current num as 2, right? Current num as 2. And the count will get 1. Again, in the next position, I is 2. Then also we have to like increase the count by 2. Again, for the next one, current num is not equals to like current num is not equals to I, right? What does it mean is if current num, let's say current num is not equals to I, then we're gonna reduce the count. Okay, we are gonna reduce the count, right? So what happens? Here current num not equals to I, then we are gonna reduce it by 1, right? Reduce it by 1. Um, Again over here, the current num not is equals to I. So the thing will get reduced to 1. Right? Again uh, for 1, it will get reduced to 0. When it will get reduced to 0, if count equals to 0, we are gonna change the current num to I. We are gonna change the current num to I. Means the current num will get changed to 1 and count would get to 1 again. Means now the current num is 1. Again, here from here current num is 1. Here current num is also again 1. We are gonna change the it is to 2. Again for this one it will get to, let's say, 3, right? And for this one, not 3, like it will get to 2 as the count is going from over here 0, 1, 2. Now over here, and the current num is not equals to I, so the current num will be 1 and this will reduce to 1. Then after that, I over here means the count will reduce to 0. As the count will reduce to 0, we have to return this one and we have to make this one current num to 2 and return this 2. So what is happening is, right, what is happening is there is like, let's say for this is a very much big example. We can think of a small example. Let's say 3, 2, 3, right? Let's took this I from here to here, right? Now over here I is 3. We are gonna make the current num as 1, right? Current num is 3. Current num is 3 and count as 1. Over here I is 2. Current num is not equals to the I. Then current num not equals to the I. Then we are gonna do count minus minus. Means count gets to 0 and this will be new current num. And then I would be over here. Then the count will be 0 and this will be new current num. And at the end, the new current num gets returned. That's the whole thing about the problem. I think you get the whole point about this problem, right? Let's write the code. Let's say current num equals to 0 and count equals to 0 also. We are gonna run in, let's say, I to nums. Okay. Now we are gonna check if count equals to 0. If count equals to 0, then we are gonna set the current num to I, right? We're gonna set the current num to I. Now, if current num is, let's say, equals to I, then we have to like increase the count plus plus, and else we will decrease the count, right? This is the whole point, and at the end we are gonna return the current num. I think this should work. Yeah. And for this thing, the approach for this approach, the complexity will be again O of n, as there is one time we are going through the error, and the space complexity will be O of 1. We are not using any kind of hash map or anything. So this is the problem. Okay. And that's it, I guess. Thank you for watching my videos. Please like, share, subscribe, and do whatever you want to do, I guess. Bye bye.